So if they tell you you've got 1.5 moles of that, you'll go 6,02 times 10 to the 23. Remember that button already makes the exponent for you, times 1.5. It's going to give it to you in scientific notation. Then it's 9,03 times 10 to the 23 atoms. If you, for example, had 2 moles of helium, then you would say 6,02 times 10 to the 23 multiplied by 2. And that gives me 1,204. If we're doing 2 decimals, we'll just end it there. 1,20 times 10 to the 24 atoms. So you could work out any number of moles of any substance. Now let's put this into a triangle because that's always useful. So we can say, look, the number of atoms, which is going to be NO, is equal to this number, okay, the 6,02, which has a special name, it's called Avogadro's number, times by how many moles I have. Okay, so the number of atoms that I have is equal to Avogadro's number, the 6,02 times 10 to the 23, multiplied by how many moles I have. So let's put that into a triangle. Okay, we've worked with triangles before, so that one would go at the top there, NO, Na, and N. And let's just write this out for ourselves. So NO is the number of atoms, molecules, particles. We'll get to that in more detail later on. This is the number of mole, and this is Avogadro's number. And that is a fixed number, just like any of your other constants that will be on the data sheet, always given to you. Now let's actually keep that triangle in front of us, and let's do some calculations using that. It's always simpler to me if I've got a triangle in front of me. So let's say that I have 5 mole of, let's say, carbon. How many atoms is that? So I'll go, okay, I want the number of atoms, so NO is equal to Na times little n. So it's Avogadro's number times by 5. So we'll just go 6,02 times 10 to the 23 times by 5, and we get 3,01 times 10 to the 24 atoms. Notice that your exponent has gotten bigger, because if you would just time this in your head, you would get 30, something, but the calculator puts it straight into scientific notation, so it moves the comma, so it becomes 3 instead of 30, so your exponent goes up, just in case that didn't make sense to you when you got the answer. Okay, let's do another one. If I said to you that you had 2,4 mole of sodium. Now, you might not like the fact that I'm giving you a fraction, but remember that this is not the number of atoms, this is mole, and a mole is a massive number of atoms. So you can get a fraction of the number of the moles. So you can say that times by the number of moles, so 2,4 times 10 to the times 6,02 times 10 to the 23, and we'll plug that into our calculator. So 2.4 times 6,02 times 10 to the 23 is equal to 1,44 if we're doing 2 decimal places, times 10 to the 24 atoms. Let's do one slightly trickier. Let's do one that's diatomic. Okay, so if I say to you you've got 2 mole of oxygen, and I ask you how many atoms that is. Okay, so we'll go NO again. Okay, we're keeping this triangle the whole time in front of us. NO is equal to N times Na. So 2 mole times 6,02 times 10 to the 23, which gives us 1,20 times 10 to the 24 atoms. Okay, now you have to remember that oxygen is diatomic. So if you're working with oxygen, what you really got here is not actually atoms. Oxygen is always 2 little oxygens bonded together. So if you've got 2 moles of oxygen, you've actually got 2 moles of diatomic oxygen. Oxygen doesn't like to be little individual atoms by themselves. So actually what you got is that many molecules. So your job is to check, if they give you something, is it something that's just a normal element or is it diatomic? And if it's diatomic, what you're actually working out is how many bonded together molecules there are. Now, if the question said work out the number of molecules, we would have stopped there. But that would have been a bit silly because they would have given it away to us so that we realized, oh, this is actually a molecule. So what they'll probably ask you is to calculate the number of atoms. They might ask both, okay, if they're helping you. But if it's a little bit of a trickier question, they'll ask just for atoms. Now, the symbol for molecules and atoms is the same. So if you want, you can always write a little subscript here once you realize, oh, this is diatomic, that is molecules, then we'll go NO for atoms. Okay, so you got 1,20 times 10 to the 24. Now, I probably shouldn't have rounded that off because it's going to make a difference now at the end. So in future, rather keep that as a long answer and then round off at the end. Now, if I have that many molecules, okay, bonded together, what would I have to multiply that by to get the number of individual atoms? Well, every molecule is made up of 2 atoms. So if I told you you had 100 atoms, or 100 molecules rather, okay, so I had 100 of these things, these 2s. How would I work out the number of atoms? Well, if I break these up, then every molecule would form 2 atoms. So I have to times this by 2 when it's diatomic. So all I do is say times by 2, and then I get 2,4 times 10 to the 24 atoms. So be very careful of anything that is diatomic, that you will have to realize, oh, this is 2 atoms bonded together. When I do this formula, I'm actually working out the molecules, then I'd have to go a step further and times it by the atoms at the end. Let's do another one like that, okay? So your job is to remember which ones are diatomic. So if they tell you that you've got 3 mole of, let's make it hydrogen gas. And just to make it interesting, they won't write H2 there, just so that you have to actually remember that it's diatomic. Okay, so if you realize that, you'll go, okay, I'll work out the number of molecules. So write a little subscript there, molecules, because it's made up of molecules. So I'll go Avogadro's number multiplied by 3, because I've got 3 moles. So 6,02 times 10 to the 23 multiplied by 3 gives me, and again, I'm not going to round this off now because it's going to make a difference, unless, of course, this was 2 separate questions and they were asking you to work out molecules and atoms. If it's just one question working out the number of atoms, rather don't round off till the end. So I realized, look, this is diatomic, so this is number of molecules. Now, hydrogen is diatomic, so every molecule has 2 atoms. So then I go, okay, all I need to do to get the number of atoms is say this number multiplied by 2. And then I get 3,612, I'm going to round off to 2 decimals this time, times 10 to the 24 atoms. Now let's do one that's a little bit more interesting. Let's do methane. Let's say you're let's make it 4 mole of methane, CH4. Okay, first job is you're going to see straight away, oh, hold on, this is not an atom, this is a molecule. So it's made up of more than 1 atom. So carbon and 4 hydrogens. So carbon and 1, 2, 3, 4 hydrogens. That's a total of 5 atoms per molecule. Okay, but we'll get to that just now. So we're going to first work out this. We're going to realize, oh, this is molecules. So when we get the answer here, we're actually getting the number of molecules, not the number of atoms. And I'm not going to round this one off. 2,408 times 10 to the 24 molecules. CH4 is made up of 1 carbon and 4 hydrogens. Now, what would I have to multiply that by to get the number of atoms? Well, just the diatomic ones every molecule had 2 atoms. Now, how many atoms does every one of these molecules have? 5. So you'll have to go 2,408, your answer from the previous one, multiplied by 5. So 1,204, but we're just going to round it off, times 10 to the 25 atoms. It's a little bit of a trickier one. If I'd given you something like NH3 and I asked you to work out the number of atoms, Then you would have done the same steps, everything. At the end though, what would you multiply by to figure out how many atoms there are? Well, once you get the answer, there's 1, 2, 3, 4, 4 atoms in total. So you would take whatever your value was from the first step and multiply it by 4.